So this is where we left off on the previous section. I do want to point out before moving on that the formula that we've discussed right here can actually apply on any arithmetic sequence, and you can change the n's and the ones to whatever you want. For instance, if I really wanted to, I could have a problem that compares like a of 20, just because this is where we left off, with a of 2. And so if I'm doing a of 20 to a of 2, then instead of having an n right here, I need to replace it with 20. And instead of having a 1 right here, I need to replace it with 2. And the common difference has to be the same throughout. So I did want to point that out because if you compare, like we found 82 to be a of 20 in the last video. It'd be 10 plus, this would be 18 times 4. And if you did that math, 18 times 4 must be 72, because if I add 10 to it, it'll give me 82. So I did want to point out before you get too busy into your homework that you can replace the n and the 1 in the arithmetic sequence with any values you want. And the same can be said when I get to the geometric sequence. And we're not quite ready for the geometric sequence, but it's pretty much the same as the arithmetic, except there's a common ratio, which means we multiply by the same number. That's why we use R for ratio. I guess the real reason why we say ratio is because it's often a fraction. If the ratio is negative, that just means we alternate signs, because if I multiply by a negative, it changes the sign over and over again. And ratio will also help you do division. And something you should know at this point in your high school career is that you know that if the pattern is dividing by 2 over and over again, or dividing by 3, whatever the number is, that's the same as multiplying by 1/2. So if you have a pattern where you're dividing over and over again, you might as well say that you're multiplying by 1/2. Or multiplying by whatever the reciprocal is. So in our problem, they tell you the first term is 4. Well, if our ratio is 2, that means the next number needs to be double that. So 8. And then double that number. So we're at 16. Doubling 16 will give us 32. So just to show you a little bit of work, I'm not going to show you a whole bunch of work, but this is a geometric. They tell you in the directions, and the common ratio is times 2. Times 2, times 2. Whereas if I look at the next one, this is how we define it recursively. They tell you the first term is 9, and now our pattern is multiplied by 1/3. So the next term would be 1/3 of 9, which would give me 3. And then the next term would be 1/3 of 3, which would give me 1. And then the fourth term, because we want the next 3 terms, would be 1/3 of 1, which would give me 1/3. So these are your next 3 terms. Again, just to reiterate that we are multiplying by 1/3 is the same as dividing by 3. But the common ratio, we always do the multiplication value. So the common ratio is 1/3 there. And then the next one is just a little bit tricky because they tell you that the first term is 3 root 2. And think about when you multiply by root 2, do this in the 3 root 2 times root 2, because that's our ratio. Well, root 2 times root 2 is 2, so we get 6 for the second term. Then the third term would be 6 root 2, because we can't multiply a whole number by a radical. So we just leave it like that. And then the next one would be 12, because root 2 times root 2 is 2, and 6 times 2 would give me 12. So those are your next 3 terms. If you're still confused, I would just encourage you to continue to work that out. And now we're going to come up with the geometric formula, and it's really the same thing. Because if I were to look at this problem, and they tell you the first term is 2, so first term is 2. Our common ratio is multiplying by 3. So the second term would be 6. 2 times 3 is 6. 6 times 3 would give me 18. Whoops, I said 18, but I didn't write 18. And then just to make sure I'm getting the right value, I know I did this earlier, that 18 times 3 is 54. So that is the value for a sub 4. But if you look at the pattern, how many times do we multiply by 3? Well, we multiplied by 3 3 times. And what's the pattern between a sub 4 and 3 times is if this is a sub n, the number of times that we multiply by it is n minus 1 times. So if I asked you to find the value of a sub 10, that means that we start with 2 and we multiply by 3 times 3 9 times. Now, how do we write it as a actual problem? Is we have 2, because that was our starting number, times 3 to the, let me write it this way, 10 minus 1 power. Because we're doing a sub 10, and we do it to the 10 minus 1 power. So if I used a calculator, then I could figure out that answer, where's my calculator? There it is, 2 times 3 to the 9th power, my answer should be 39,366. I already forgot what it was. 366. But what are we getting at? Is if I ask you for the nth term of a sequence, you start with your first term, and then you multiply by the common ratio to the n minus 1 power, because it's repeated multiplication. Now, as I mentioned earlier, this is very similar to the arithmetic. So this is geometric. Let me switch colors and talk about the arithmetic for a second. Because in arithmetic, we did a sub n is equal to a sub 1. Instead of multiplication, it was plus. And then we did, I forget how I always write it, but remember, multiplication is commutative, so sometimes I put the d in front. This is your arithmetic. And notice the similarities. Is they both start with a sub 1. You need to know the first term. Because in arithmetic is addition, we add, but geometric is multiplication. Now let's think about it for a second. If we are repeating addition, it turns into multiplication. So we're adding the same number over and over again, which turns into multiplication. And it's n minus 1 because of the relationship we talked about earlier. Whereas geometric is repeated multiplication. Well, how do we do repeated multiplication? We do exponents for repeated multiplication. 3 times 3 times 3, however many times turned into 3 to that power. And that is your shortcut to do these formulas. So I believe you're ready to do your homework. You might want to put a giant box around these two formulas. So then when you go to your homework, you can look at this. Now, we've done a few problems like this. I'm trying to find one where you might want to consider using the formula and pay close attention to the directions. So write down the arithmetic formula. D is 7. You know the 22nd term is given by this. And you need to find the first term. So using the formula. Moving on to the next section of the homework, being able to answer some of these questions. And feel free to write down any questions that you have, and hopefully I can answer them. So if you notice number 10, you have a geometric sequence, you know the first term, you know the fourth term, and they ask you for the 10th term. And maybe one more thing before just setting you free to work. I do want to point out that these n's and these 1s do not have to be n's and 1s. You could put 22 in for n. I just said that because that was one of the problems that we just had. And if you change your first term to be like a sub 3, or I'll just say a sub 3, then you have to change this one up here to be 3 as well. So maybe I should emphasize in this problem that if you change this value, then you have to change this value. And if you change this term, if you're talking about the third term, then you have to change this number to be 3. So those things go together in the problem. And I already talked about that with the arithmetic. I don't think I'm forgetting anything else, but if you have any questions, feel free to write them down and bring them to class. I look forward to it. And you're ready for your homework.